Good morning and welcome to Tuesday's Maths. So yesterday we started our 3-day mini rewind on angles. So yesterday we looked at all the different types of angles. We remembered that there was how many degrees in a triangle? 180. How many degrees in a quadrilateral? 360. How many degrees around a point? 360. And how many degrees in a straight line? 180. So today we are going to use all of that and a few more facts about angles to help us solve some problems. Right, let's get started. Okay, first of all, we have got a little rewind. So have a look, gather your facts, what do you know? And then there is another rule that we didn't look at yesterday that hopefully you can remember. So have a bit of a think, pause the video, and then we'll go through it. Okay, first things first, gather the facts you know. Well, we know that this is around a point where there's 360 degrees around a point, so that we know 100 degrees plus A plus B plus C is going to equal 360 degrees. Right, there is something else that we know though, and you might have forgotten this rule, but there is a rule that if you've got straight lines that intersect each other like this, so straight lines that intersect each other like this one as well, the angles opposite each other are equal. So if this angle's 100 degrees, which other one's going to be 100 degrees? B, because these two are opposite each other. So if we look at this one quickly, same thing, look, because the straight lines intersect each other. So which other angle can you work out straight away? Well, if you know that this one's 43 degrees, you know that this one, E, is also going to be 43 degrees. Right, have a look at this one. Does this one follow my rule? Is this one two straight lines intersecting? Well, this might look like it, and some people would make the mistake that these two are equal and G and H are, but it's not, because this is a straight line drawn with a ruler that goes all the way through. This one, though, is at one angle, and then if that line carried on, it would go down here. But instead, the line goes this way. So if this carried on, it would go up here. So for this one, this rule does not apply because these are not two straight intersecting lines. These ones are, and these ones are, because the line carries on. So if we know that this is 100 and this is 100, how can we work out A and B? Well, if these two are equal, I also know that A and C are equal. So if I know that B is also, ooh, that was a big zero. It's really hard to do this through the screen. If this is 100 and this is 100, together that's 200. The whole thing's 360. So 360 take away 200 is 160 degrees. So I know that A plus C is 160 degrees. Now these two are equal. So what can we do to work out what one is then? If together they're 160, so two angles are 160 degrees. So one angle will be 160 divided by 2, which would be 80 degrees. And so would this one. Okay, now have a go at this one. Pause the video, off we go. Well, if this one's 43, I know that E is also 43 degrees. If I add those both together, 40 add 40 is 80, 3 add 3 is 6, so it'll be 86 degrees. The whole thing is 360 degrees. So I want to do 360 degrees, take away 86. So 0 take away 6 you can't do, so we need to rename. 10 take away 6 is 4. 5 take away 8 we can't do, so we need to rename. So 15 take away 8 is 7. 200 take away 0 is 2. So I know that F and D together both equal 274. Right, so they both together equal 274. So I need to divide them by 2. So 274 divided by 2 is going to be 137 degrees. Well done if you got those right. Okay, now we've kind of got all the facts that I think we need to know. We're going to have a go at Unit 14's problem solving lesson. It's lesson 13, all about shapes and angles. So this is going to be using all the learning from yesterday and that little rewind that we've just done. So here is question 1. I want you to read the information, gather your facts, pause the video and have a go. Right then, answer time. So first things first, gather your facts. What do you know? Well, I can see there is a rectangle, and I know that a rectangle is a quadrilateral, so I know that all the corners will add up to 360 degrees and they are all 90-degree angles. I can see that inside that is a triangle. The question is telling me it's an isosceles triangle. Now I know a triangle, the interior angles add up to 180 degrees, and because it's isosceles, I know that the two bottom corners, the ones near A and B, they are going to be the same because it's an isosceles triangle. It has two sides the same, two lengths the same. So I know that the two bottom corners are going to be the same length. So I'm going to start there. So I'm going to do 180, take away 116 because there's 180 degrees in a triangle and the top angle is 116. That would be 64. Then I'm going to divide that by 2 because I know that the other two angles are equal. So I know, as you can see on the second diagram, that the two bottom angles of the purple triangle are 32 degrees each. Right, I'm going to do A first of all. So I can see that A plus 32 degrees, together that's making a right angle. And we know a right angle is 90 degrees. So I'm going to do 90. I'm going to take away 32. So I know that angle A is 58 degrees. Now I'm going to have a look at B. So B, I can see, is on a straight line. So I can see that B plus that 32 degrees plus that small angle are all going to add up to 180 degrees. Right. Problem is, though, I don't know what that small angle on the left-hand side is. So I'm going to have to do a little bit of fact work, a little bit of problem solving to work that out first of all. Well, I can see that actually A, the right angle, and this small angle have created a kind of triangle, a right angle triangle, all by themselves. So I know that a triangle has 180 degrees. I'm going to do 180, take away 90, take away 58, which is 32 degrees again. So angle B is 32 degrees, and that small angle is also 32 degrees. Right, now I can work out B. So I can do 180, take away 32 degrees, take away 32 degrees, which would be 116 degrees. So B would be 116. Well done if you got that right. Okay then, think together, question 1. This diagram includes an isosceles triangle, and I want you to try and work out what are the sizes of A and B and what are the sizes of angles C and D. Remember what we rewound to at the start. Pause the video, have a go. Okay then, answer time. So first things first, gather the facts. What do you know? Well, I know that this is the isosceles triangle here. These two lines here tell me that this length and this length are equal. So that then tells me that this angle and this angle are equal. So I know that A and B are both the same. And I know that this and this and this is going to be 180 degrees because it's a triangle. Here we have got a point. So the angles around a point there is 360 degrees. I also know, because this was the start of the rewind at the start of the lesson, that if you've got two straight lines that intersect, opposite angles are equal. So I can see that D and C are going to be equal. And I can see that this angle and this angle are going to be equal. So I've started labelling what I know. Well, if this is 86 degrees here, then this side is also going to be 86 degrees. If I know the whole triangle here is 180 degrees, I'm going to do 180 degrees, take away 86, which would be 94 degrees. Halve it, because these two are the same. So 90 halved is 45, 4 halved is 2. So this would be 47 degrees, and so would B. Right, now I'm going to have a look at this section here. So this is 360 degrees. I'm going to do 360 degrees. I'm going to take away 86 and I'm going to take away the other 86 and I'm left with 188 degrees. So I know that C and D together add up to 188. These are equal, so 188 divided by 2 should be 94 degrees. Well done if you got those right. Okay then, here is question 2. So this time we have got a scalene triangle. What does a scalene triangle mean? It means that all the lengths are different and all the angles are different. So work out angle M first of all, and then have a go at N. Off you go. Okay, this is another one where you've got lots of different things to work out. You know you've got a triangle, you know a triangle's 180 degrees. Here you've got a point, you know there's 360 degrees around a point. And here you've got a straight line, you know there's 180 degrees in a straight line. If you know all of that, you can work this out. So This is a straight line, it's 180 degrees, so 180 take away 107 would leave you with M as 73 degrees. Now I need to work out this angle here so I can work out angle M. So I'm going to do 73 add 32, take that away from 180, which would be 75 degrees. As we know, this is 360 degrees, so 360 degrees take away 75 degrees would be 285 degrees. Well done if you got that right. Right then, it's time for our workbooks. So if you've got your workbook, it's page 81. If you haven't, don't worry. These are on Dojo and Google Classroom. Here is question 1. Here are questions 2, 3 and 4. 4 has got that little light bulb sign next to it, which means it's a bit of a challenge and means you're going to have to think about it a little bit. Okay, it's a little bit of a challenge, that one today. I used algebra to work it out, but you might be able to work it out a different way. And if you want an even harder challenge, here is question 5 for you. But again, you don't have to do this one. This is just the challenge if you would like a little bit of an extra task to do. Okay, pause the video and then we'll go through the answers. Okay, answer time for number 1. So starts off nice and easy. You know it's a triangle. You know the whole thing's 180 degrees. You also know that you've got a straight line. So on your straight line, you know your straight line is 120 degrees plus something to make 180. So I knew straight away without writing anything down, use my mental maths, I knew 180 take away 120 is 60 degrees. And I've labelled that on my diagram. Then I know that the right angle is 90 degrees. So I did 90 add 60, as you can see on the working out, which is 150. Then I knew the whole triangle was 180, so I did 180 take away 150, which was 30 degrees. For B, I could see it was a square, and I know that all the corners of a square are right angles, so I knew that that was 90 degrees there. I knew that 48 degrees then plus the 90 plus B were on a straight line, so they had to equal 180. So I did 48 plus 90, which was 138 degrees, and then I did 180 take away 138, which told me that B was 42 degrees. And for the last one, I knew that this was an isosceles triangle. I knew that C and D were going to be the same angle, the same answer. Altogether, there's 180 degrees in a triangle, so I did 180 degrees, take away 44, which was 136, and then I divided that by 2 because C and D are both equal to get 68 degrees. Okay then, with this one, I've done some, used some highlighters to colour bits of these in, so hopefully you can see it a little bit more clearly. So, calculate the sizes of angles A and B. First things first, again, look at what you know. So it's a rectangle altogether. So each corner is 90 degrees. So I know that this is going to be 90 degrees. So actually that can help me work out A straight away. If I know that together this is 90 degrees, I can do 90 take away 35, which would be 55. So I know that A is 55 degrees. To work out B then, I can see that here there is a triangle. So I can do 180, take away 90, which is your corner, take away your 55 degrees, which is A, and B would then be 35 degrees. There is also another sneaky little way you could have done this. If you could, we did touch on this very, very briefly. If you have got a Z angle like this, you can see it makes a Z shape, where these two lines, the top and the bottom of the Z, are parallel, then the inside of the kind of Z, the inside angles are equal. Okay, so you could also have worked it out or proved it that way. It's a bit of an extra, a little bit of an extra knowledge there for you. Okay, how could you have found size of angles C and D? Now, there is a couple of different ways you can do this. You can look at the fact that here you have got a quadrilateral. So you could have added 90, add 90, add 35, take it away from 360, and that is C. Or you could have done it the way I did it, which was I knew that this was around a point, and I knew that the whole thing then was 360 degrees, and I took away 35 degrees and 35 degrees because these are opposite angles, because they're on straight lines. I've done it in pink so you can see at their opposite angles they are equal. So 360 take away 70, which was 290. I know that these are the same, so I divided them by 2, which was 145 degrees. You could have also looked at it and seen that C and B together make a straight line. So you could have done 180 degrees, take away 35 degrees, which would have been 145. That's probably actually the most efficient way of doing it. Okay, but sometimes it's what jumps out at you first. And you know that they are the same because they are on straight lines that intersect. So C and D would have had the same answer. Lovely, well done if you got those right. Okay then, here we've got a square. So each one of these is 90 degrees, and I've drawn a little right angle here to remind me of that. And we've got a scalene triangle. Scalene triangles, everything is different. So I just started adding in everything I knew, okay? And that's usually the most simple way to do this, okay? Actually, you could work out y very easily because y is on a straight line. The whole thing adds up to 180. Take away 80, so y would be 100 degrees. Here in the corner, you know that this is going to be 90, but you didn't know what this angle was here. So I knew that this here, I'm going to draw it in pink so you can see it. This here makes a triangle. This is why I always say gather your facts, because it's about finding all of the different shapes and all the different things you know. So this is a triangle. So I did 180, took away the 90, which was the right angle, and then took away 52, which was up here, and got left with 38 degrees. So I knew that this angle here was 38 degrees. Then I knew that this here is a right angle because it's the corner of a square. So I did 90, take away 38, which is 52 degrees. So Z would then be 52 degrees. And now I knew that once I'd worked that out, I could see that this is also a triangle. So I could do 180 degrees, take away 152 degrees because these two equal 152, which would have left you with 28 degrees. Really well done if you got that right. Okay, I used a bit of algebra to work this one out, so apologies, but for me, I think this is the easiest way to do it, and it never hurts us to rewind our algebra. Okay, that never hurts to recap that. So 3 angles meet at a point. I've started to visualize this by drawing this out. Okay, so I know they meet at a point. What do I know about a point? I know the whole thing is going to equal 360 degrees. We've got angle X, which is 40 degrees larger than angle Y. Okay then, so I know that angle Y is my kind of smallest one, and I've called it Y. And I know that angle X is 40 degrees bigger, so I've called it X. If I know it's 40 bigger than Y, I've actually put Y plus 40, because I know it's the same as Y, but plus 40 degrees. So I've called it Y plus 40. Then I know that angle Z is double the size of angle X. Okay then, so I've drawn angle X as angle Z, sorry, is the biggest angle. And I've actually written this as it's 2 lots of Y plus 40, because remember, when you've got a number outside the brackets, it means 2 times. Mathematicians are lazy. Okay, we're nice and efficient and we want to write things as quickly as possible. So this means 2 times Y plus 40, or 2 lots of Y plus 2 lots of 40. Okay, so what I did then was I started looking at, well, how many Y's have I got all together? Well, I've called this Y. Let me colour this so we can see it. So I'm saying that this is 1Y. This angle here is 1Y. And this angle here is the same as 2Y's because it's 2 times as big as this. I've got 1, 2, 3, 4 Y's. There it is. Or here it is. All together. Then, what else did I have? Well, I added 40 degrees, and then I had 2 lots of 40 degrees. So I had 120 degrees altogether. So, and I know that because it is a circle, I know that this is going to add up to 360 degrees. Now, if you rewind all the way back to when we did solving equations, okay, I know this is a long time ago and I know this is a bit tricky. What do you need to do to get rid of plus 120? Well, you need to take it away. So if I take 120 off that side, take 120 off this side, so 360 take away 120 is 240. 4y equals 240, so divide it both by 4, y equals 60. That one was really, really nasty, so well done if you got that right. I'd be very impressed. The other way I'm going to try and explain this is by using a bar model. So this is angle Y, just 1y. This is angle X, which is the same as Y plus 40. And this is angle Z, which is Y plus 40, Y plus 40, because it's twice as big as angle X. Okay, we know that the total of all of this all together is 360 degrees because it's all around a point. So now what I'm going to do is I'm just going to start taking away, I'm going to start covering things up so that all we're left with is the y's. So 360 degrees, I'm going to take away 40, so it's now 320 degrees. I'm going to take away another 40, so now it's 280 degrees. I'm going to take away another 40, so now it's 240 degrees. And we've now got 1, 2, 3, 4. 4 equal pieces, 4 equal parts to share this 240 degrees between. And this is the same as before when we had 4y equals 240. That's basically what we've got here, and just in a different representation. So we've got 1, 2, 3, 4 y's equals 240 degrees. So we need to share out this 240 degrees. 240 divided by 4 is 60. Okay, so each y is 60 degrees. So y itself then is 60 degrees. Angle x, oh sorry, got a bit blurry, is 60 degrees plus 40. So angle x is 100 degrees. And then z is twice as big as x. So z would be 200 degrees. Fantastic work if you got that right. That was really tricky. And if you've done the challenge, I think the challenge is actually easier than number 4. So we'll have a quick look at the challenge. Well, first thing I did was I saw that I had a quadrilateral and I labelled my right angles. So I knew that I had 2 right angles and then B and C, and together they equaled 360. Now look at the green lines. I could see that they were straight lines that intersected, so opposite angles are equal. So B is going to be the same as the one opposite, which is 140 degrees. So to work out C then, I did 360 degrees and I took away 180, which was my 2 right angles. Then I took away 140, which left me with C as 40 degrees. Then to work out A, I knew that that was 360 degrees around a point. So I did 360 degrees, take away 140, take away 140, which was 80 degrees. And I knew that because they are opposite angles, A and the one opposite it are equal. So I did 80 divided by 2, which is 40 degrees. And a way you also could have done this, you could have proved it. If you look at the pink lines, hopefully you can see they make a kind of Z. The top and the bottom are parallel, so the inside angles are equal. Okay, that's a bit of an little extra tip for you. Right, really, really well done for having a go at all that. Fantastic work. See you tomorrow.